Hello everyone. In this video we are going to talk about logarithmic functions. In the previous videos we talked about exponential function. We can write an exponential equation as a logarithmic equation. Let me give you a simple view of exponential equation and logarithmic equation. We have b to the power x equals to a as a exponential function. In here we have log to the base b a equals to x. As you see, here we have a base, and here for log, here also we call this one as a base, and our exponent will be a result in a log. Now let's convert from the exponential function to logarithmic function, or vice versa. Let's talk about it. In example 1, we have converting from exponential function to logarithmic form. For branch A, we have 2 to the power 6 equals to 64. Now to change this one, to convert it, we are going to write log. Our base is 2, so we write it here, and our exponent will be result, which is 6, and the remaining we will write it here. So this is how we take the convert of exponential function to logarithmic function. Let's have another example. We have branch B we have 4 to the power 1 equals to 4. To change this one to logarithmic function, we have log, and our base is 4, we write it here, and equals to an exponent, which is 1, and the remaining number is 4, we write it here. This is simple. It is like that. All of the examples is like that. For example, what if we have 5 to the power 0 equals to 1, and branch D we have 5 to the power negative 2 equals to 0.04, and branch E we have 3 to the power x equals to 81. This is 81. Now let's convert them to the logarithmic form. So we have log, just write log, and our base is 5, write 5 here, and equals to exponent, which is 0, and the number that's remaining is 1. Or I will give you a note that log of 1 equals to 0. And then log for a base, which is 5, equals to an exponent, which is negative 2, and the remaining number we are going to write next to the logarithm. This is how we take the inverse. And that one, log base, which is 3, and equals the exponent, which is x, and the remaining number we are going to write it here. This is how we convert from exponential to logarithmic form. Now in example 2, it said converting from logarithmic to exponential form. Okay, this is the same process. We have the base, which is 10. We have the base, which is 10, and our exponent, we have it here, equals to 100. Or we can use simply this way: 10 to the power 2 equals 100. We can do like that. Let's try from this example. 7 to the power 2 equals to 49. So it will be 7 to the power 2 equals to 49. This is how simple is this. We have 8 to the power negative 1 equals to 0.125. A to the power negative 1 equals to 0.125. In here, we have 5 to the power 1 equals to 1. 5 to the power 1 equals to 5. And in here, we have 12 to the power 0 equals to 1. So 12 to the power 0 equals to 1. This is how we convert from logarithmic to exponential form. In example 3, we are going to evaluate in logarithms. But before doing this, let me give you some notes. There's log base b and b, and that one equals to 1, because the bases are the base and the number next to a logarithm are the same, so the result will be 1. For example, if you have log 5 to 5 equals to 1, because the base and the number next to logarithm are equal. The second note, we have it here, which is log whatever the base is, and then this number log 1 equals to 0. For example, we have log 7, let's say 7 to 1 equals to 0, because 7 to the power 0 equals to 1. And another note, if you have a logarithm like this, we assume that this number, if you don't have a base of a log, we assume that this is 10. For example, if you have log 100, it means we have log base 10 100. And now let's solve or evaluate some examples, some logarithmic. We have log 1000. We can say that log 1000 equals to x. We want to find the value. So we don't know the value, we assume that this is x. And then change to exponential function. We said that this is 10 to the power x equals to 1000. So 10 to the power x equals to 1000. So 10 to the power what equals to 1000? 10 to the power 3. So x equals to 3. This is the first way if you don't have a calculator. So what if you have a calculator? We have a simple way. We can write like this. Log, this is 10, log 1000 equals to, we can use this one. We write log 1000 divide by log 10, because we have 10 here, so we divide like log 1000 divided by log 10, so equals to log 1000 divided by log 10 by a calculator equals to 3, so the result is 3. For branch B, let's solve it by first way. If you don't have a calculator, we assume that this is equals to x, so we change it to exponential form. 4 to the power x equals to 1 over 4. 4 to the power x equals to 1 over 4. So 4 to the power what equals to 1 over 4? The negative power can flip the number. So x equals to negative 1, or you can try by a calculator. 4 to the power negative 1 equals to 1 over 4, or 0.25. This is the first way. And the second way, if you have a calculator, you can simply use this way. We have log 4 and 1 over 4 equals to log 1 over 4 divided by log 4. As you see, we change both bases to 10, So that's why we can solve it, and equals to -1 if you do it by a calculator. We have checked out examples to solve. Branch A said and branch B said log base 25 of 0.04. It said evaluate these logarithmic. We can assume that this is equals to x and change to exponential function. We have 10 here because it's not given, so 10 to the power x equals to 0.001, and then we can try by a calculator. As you see, we have 4 zeros here and 1, so it means x equals to -5, because 5, you can try it. 10 to the power -5 equals to this number. So the second way, we can immediately write log of 0.001 over log of 10. So immediately by a calculator, if you do it, equals to -5. And now we have the second one, which is branch B. We assume that this is equals to x, and 25 to the power x equals to 0.04. So 25 to the power x equals to 0.04. Then if we have, let me give you this hint. If you have a negative number, if you have a decimal in one side, try from -1. 25 to the power -1 equals to 0.04. So x equals to -1. And the second way, if you have a calculator, we have log of 0.04 divided by log 25 and equals to -1. Now let's continue to solve more examples about those 3 examples that we solved. In example 1 section, it says write each exponential equation in logarithmic form. So we start from 2. 2 said 2.4 to the power 0 equals to 1. It said write this one as the logarithmic form. So to change it, we write log, and our base here is 2.4, and the exponent, we said it will be our result, which is 0, and we have the remaining, which is 1. Or you can say that 2 to the power 0 equals to 1. Let's solve 3. Let's write all of them and then solve them. Now, first write log, and our base is 4, and the result will be 1.5, and the remaining we have 8. That's it. It's as simple as that. First write log, the base we have, this base with this base of log is the same, right? 10, and our exponent will be result, as we mentioned, -2, and our number and the result of exponential will be here, 0.01. Look at this one. We have log, and the base will be 3, and our exponent will be a result, and this number is remaining 243. That's it. That's how we solve it. And for the section 2 example, we have write each logarithmic equation in exponential form. Now we are going to change the logarithmic to exponential. What is the base? We have 4 to the power negative 2 equals this number. So 4 to the power negative 2 equals 0.0625. That's how we do it. X to the power 3 and equals to negative 16. So it will be x to the power 3 equals to negative 16. And here 0.9 to the power 2 equals 0.81. So it will be 0.9 to the power 2 equals 0.81. And in here we have log 6 to the power 3 equals to x. So 6 to the power 3 equals to x. That's how we convert. That's how we write logarithmic equation in exponential form. In the examples 3 section said evaluate by using mental math. So in here we have a logarithm. We are going to evaluate them. So as we studied, we have 7 here, log base 7 343. We assume that this is equals to x. So we can say that 7 to the power what equals to 343. So 7 to the power x equals to 343. This is the first way. If you don't have a calculator, we can use it. We know that 7 to the power 3 equals to 343. So it means x equals to 3. Or the second way that you can do is trying by a calculator. For example, we can immediately write log of 343 over log 7. We change the bases to 10. This is 10 and this is 10. These bases here. And these bases are the 10. So we change them immediately by a calculator equals to 3. This is easy. I recommend you to use this way if you have a calculator. Now the question said solve it by mental math. Let's solve it. We have here, we can say this is, we assume that equals to x, and log base 3 1 over 9 equals to x. Now we can say that 3 to the power what equals 1 over 9. 3 to the power what equals to 1 over 9. 3 to the power x equals to 1 over 9. We can solve it like that. We can flip this 3 or flip 1 over 9. I think it's easier to flip 3. It will be 1 over 3 to the power negative x. We change the sign of the power and 1 over 9. So 3 to the power what equals to 9? 3 to the power 2. So it means our x equals to negative 2. Why? Because this negative here, it will be x equals to negative 2. Or we can use this way by a calculator. We can immediately say log of 1 over 9 over log of 3. That's it. Let's try it by a calculator. We have log in a parenthesis 1 over 9, 1 divided by 9, close the parenthesis, and divide by log 3. You will get negative 2. So here you can write negative 2. That's how you get the result. And we assume all the time we assume that this log expression equals to x if we do it by a mental math. So 0.5 to the power x equals to 0.25. 0.5 to the power x equals to 0.25. We know that. You can try it. 5 to the power 1 is 5. 5 to the power 2, it will be 0.25. So x equals to 2. If we use a calculator, log of 0.25 over log of 0.5. Every time write this one in the numerator and write the base in the denominator. So let's use a calculator now. We have log of 0.25, close the bracket, divide by log of 0.5, and you will get 2. This is how simple is this. If you do it by a calculator, I recommend this way. For number 13, why don't we try by a calculator first? We have log of 1.44 divided by log of 1.2 immediately by a calculator. We have log of 1.44, close the bracket, divide by log of 1.2 equals 2. That's it, equals 2. So now let us do it by a mental math. Just equalize it by x, log 1.2 base, and of 1.44 equals 2 by x, because we want to try by x. So we say 1.2 to the power x equals to 1.44. So we know that if this power is 2, it will be 1.44. So it will be x equals to 2. That's it. Thank you for watching.